increasing function defined for x is greater than or equal to 0. The table gives values for f of x at selected values of x. The function g is given by g of x equals x to the third minus 14x minus 27 over x plus 2. So there's multiple parts to it. We're going to break it into parts. And so the first one, we're going to do a, which is Roman numeral 1. The function h is defined by h of x is equal to g of f of x, which is g of f of x. So I'm just going to write the second part, g of f of x. Find the value of h of 5 as a decimal approximation. And remember, in the directions, they say to round to 3 decimal places. So we're going to round to 3 decimal places. Or indicate that it's not defined. Okay, and show the work that leads to your answer. So let's do this part first. So we want to do h of 5. So I'm going to substitute wherever we see the x, we're going to put the 5. And remember, you always do the inner part first. So we're going to find where x is 5, the f of x. So when x is 5, this is the f of x. So this part here is 34. Now we're going to do the g of 34. Now, of course, you can plug in 34 into this equation, right? So 34 to the third minus 14 times 34 minus 27 all over x plus 2. Or I use the calculator. So let me show you the calculator method. So as you can see here, first you press y equals, and then you put the rational equation, okay? X to the third minus 14x minus 27 all over x plus 2. Then you're going to press quit. So that would be second mode, and you have a clear screen. Once you have the clear screen, then you're going to click on vars, and then you use your right arrow to go to y vars, and then you press enter. And when you do that, you're going to end up having y1. And remember, we wanted the y value when x was 34. And so we get this fraction. Now remember, we want it in decimal format, so then you press math. And then you get the screen, and you're going to click on number 2 and enter for the decimal. And then this is what it is in decimal format. So let me go ahead and answer the question. So once again, we plugged it into the calculator. And so we got 1077.8055. So if I were you, I'd always write the 4 numbers after the decimal, and since the main direction said to round to 3 places after the decimal, it'll be to the thousandths, and so when you look at the next number, it becomes 806. So g of 34, I'm sorry, I should say h of 5 is this number, because that's what the question asked. All right, so now let's look at Roman numeral 2. So now we're going to look at A, Roman numeral 2. It says find the value of f inverse of 4, or indicate that it is undefined, that is not defined. So first of all, whenever we're talking about inverse, the y becomes the x, and the x becomes the y, right? We're switching. So just like that, when you want to find the inverse of 4, you're really finding the x coordinate when the y value is 4. Okay, so usually we say f of 4, that means y, right? But because this is the inverse, we're looking for the x coordinate when the y value is 4. So when you go back to the table, we're looking for the x coordinate when the y value was 4. So the y value was 4 here. So the x coordinate was 3. So the f inverse of 4 is 3. So that's the second question. And now let's look at B. So in B, it says find all values of x as decimal approximations for which g of x is 3 or indicate there are no such values. Well, remember, this is our main function, and we already put this in the calculator in y equals when we solve for this. So that'll help us now. Now we want to know when this function is going to intersect with this, when the y is 3. So we're going to put this in the calculator. So here I show you that we are in the we're in the calculator, and we already had the y1 equal to the rational expression. We already left that there from before. Now in y2, you're going to put 3, and the reason why you're putting 3 is because you want to know when it meets or intersect with y equals 3. Okay, so that's what we do. And so once you input the y2, then you're going to press second trace for calculate. And when you do that, you see the screen. We're going to click on number 5 for intersect. And when you do that, you're not going to be able to see the graph fully. So then what do you do to see the graph fully? We're going to click zoom, and you're going to have a bunch of lists, and I decided to choose 0 for zoom fit, so it could fit in the screen. And when you do that, this is what the graph looks like. And as you can see, one color is in blue, the other one is in red. And this one is actually the first graph and then the second graph. That's the g of x equals 3, okay? So let's go ahead and press second trace for calc again. And when you do that, this is the screen you get. And we're going to hit on 5 for intersect because we want to know where it intersects. And when you do that, this is what shows up on your screen. So the question asks first curve, and that's the blue one. Blue equation, blue graph. So you use the arrow keys to make sure that this little cursor is sitting only on the blue equation. And then you press enter. Then the next question shows up, second curve. So make sure you move the cursor, so you're using your arrows. You move your cursor so it's only touching the red graph for the red equation. y2 is 3. And then you press enter. And then the second question shows up. Is that your guess? Well, I decide to move the cursor where the point of intersection is between the blue and the red. And then I press enter. And then the calculator goes, nah, it's actually this. So this is the point of intersection. So this is the x value when those two graphs meet. And so let's copy that down. Okay, so we were up to this part here where we're doing B, and it says find all values of x. Okay, so it was x equals, so I'll just write second trace, and that was for calc. And then we press 5 for intersect. And then we got x equals 4.8753. So like I said, when you get a lot of numbers, copy the 4 numbers after the decimal, and then you're going to round to 3 numbers after the decimal. So when you look at the next number, x becomes 4.875. Okay, so we finished B, and that was I, so this is BI, so we got this part. Now we're up to the next part, so we're going to do that in purple. It says determine the end behavior of G as x decreases without bound. So you need to understand what this means. When it says x decreases without bound, that is limit as x approaches negative infinity, because it says decreases without bound. It keeps going, and then we're going to do this for g of x. So what we're going to do is use the calculator again. So when you use a calculator, we want to see what the graph looks like. And I guess I can use this graph here. Keep in mind, they were talking about g of x, so that's the blue graph right here. And remember, when I'm going towards the right, that's when x approaches positive infinity. And when I'm going towards the left, that's when x approaches negative infinity. So as x approaches negative infinity, where is the graph going? It constantly is going up, so that's positive infinity. So as x goes towards the left, the y is going up, so positive infinity. So let's go ahead and write that using limit notation. So the limit as, so the limit as x approaches negative infinity for g of x is positive infinity. Now, just for practice, let's practice what if the question was something like of the idea of x increases without bounds. And then if it was x increases without bound, then it would be the limit as x approaches positive infinity for g of x. And let's see what that looks like on the graph. So this is the same graph, so we'll look here. So remember, as x approaches positive infinity, we're going towards the right, and as we're going towards the right, the graph is going up, and still it is still positive infinity. So it would still be positive infinity. Okay, but the question only asked for this. Now let's look at C. So we did this part. It says, based on the table, which of the following function types best models function f? So is it linear, quadratic, exponential, or logarithmic? So what we're going to do is look at the table. I'm just going to clean the table up a bit so it's more neat. And here it says... I guess I'll do blue. Okay, so when I'm talking about first difference, I want to know how do we change from negative 10 to negative 5? And well, that's a plus 5. Here, let me erase this too. Okay, sorry. Okay, so here, this is plus 5. And then how do you get from negative 5 to 4? That's a plus 9. This is a plus 13. And this is a plus 17. This thing, the first thing here we did is called the first difference. Now, if the first difference was constant, then this would have been linear. So if the first difference is constant, then it would be linear. But as you can see here, it is not linear because it's not constant. Okay, so let's try again. So how do you get from 5 to 9? You add 4. How do you get from 9 to 13? Add 4, add 4. Now this is called the second difference. And as you can see, the second difference is constant. And when the second difference is constant, it is called quadratic. So therefore, for this question here, I'll just put an arrow here. This answers C, Roman numeral I. So that was quadratic. Okay. All right, so now we're up to the last part of the question. It says, give a reason for your answer in part C based on the relationship between the change in the output values of f and the change in the input values of f. Refer to the table in your reasoning. So it's basically what I kind of explained here, but we're going to put that in words. So this is look like a big maze. Okay, so let's put this here. So this is part C, Roman numeral 2. So what we're going to say is because the second difference is the same or constant, f is quadratic, and that's because the difference of the difference is constant.